Thanks, everybody. I would firstly like to give thanks to the professional team sitting with us on the table here. Daniel from RMCE as the structural engineer on this project. Philip Boyser, Permanent Formwork Solutions, as the contractor who has installed the GRS product, the product that we have nominated. And the project we have nominated is the Richmond Steel Bridge in Steelpoort. It's sort of a redevelopment of an existing bridge. The professional team will walk us through the scenario that has occurred on the project, the reasoning for the redevelopment. From Global Roofing side, we just want to thank everybody for this opportunity, the SAISC team, to give us a platform to showcase our products, our services, and our projects. I'd like to just move on to the project brief. The client is Two Rivers Platinum Mine. Project is situated in Steelpoort, South Africa. As the engineers I've mentioned, Daniel, would you like to introduce yourself quickly?
Hi there, I'm Daniel Eden from RMCE. I was the structural engineer on this project for our team. If you want to move on to the project brief, I'll explain a bit more about the project. So this project was to replace an existing bridge. So the original bridge was actually more of a culvert type bridge, and it got overtopped and during a flood, and it almost got completely destroyed. So the brief was to replace it with a clear span of 25 meters, which almost doubled the existing bridge. So it was quite a big span to deal with. The bridge required a road width of 7.5 meters, so it can be a double lane, and then a walkway on the one side. The constraints, as you can see there, was that it needed to be prefabricated off-site and then assembled on-site. So we elected to go for a composite deck to achieve the span that we were looking for, and to ensure that we could meet all the requirements for constructability, and so that we could have the freeboard required so that this bridge wouldn't get overtopped again by another flood.
Yeah, fantastic.
So this is the part of the brief. This was the trucks that they were intending to use this bridge. However, the loading from TMH7 actually exceeded this, so we followed the code and used that loading rather. And then here's some of the benefits of using steel. It was, in terms of the constructability and being able to get everything right off-site, bring it on-site, plug it in, and build it. It was the only real solution for this kind of project and for the time constraints. And the composite action of using the deck with the steel frame helped us to achieve the span we were looking for and meet all the other requirements of the project.
Great stuff. Neil, anything from your side on the QC transport to site?
Yeah, well, on the QC panels, of course, it's lightweight. I reckon to get a crane into the, to do a different type of bridge construction. I don't know all the limitations that they had on site, but with QC panels being light, it can be installed by hand. There's plenty benefits to that, and I think
yes, of course,
the benefits of that actually talk towards what they had to achieve.
Great, man. Yeah, just on the overview side, the project was, if I have that correct, was completed the beginning of February this year. Am I correct, Philip?
Yes. There and thereabout.
Yeah, and we then of course supplied the total value of about 180,000 rand. That was just for the QC flooring that was supplied to site. 25-meter clear span bridge, which is quite extensive. Just on the overview, so this was G4 Mining with the main contractor. Philip, anything on your side on the scope of works of the deck itself, timing, and any developments on your side on how this was achieved?
So yes, so obviously with the constraint being a river underneath the bridge, conventional backpropping just was the biggest constraint there. And obviously the specified material from RMCE side was the special bend QC that could span the 3 meters flange to flange without any backpropping required.
Yes.
So obviously the GRS product there was the right way to go. Some constraints we had is the shear studs that was supposed to be a through deck weld. In normal instances, we would have liked to have one long multiple span of QC deck spanning across the beams. But in this case, with the constraints of power or sufficient power on site for the shear stud welding, we had to install the shear studs off-site in the manufacturer's yard, and then obviously single spans in between the shear studs, which made it a bit more difficult. But once again, due to the flange spacings we had and the thickness of the material and the special bend profile that GRS offered, it was obtained, and we could actually install quite fast on site. Material deliveries was no issues. So I think just out of an environmental issue with the river flowing underneath and the propeller system we used, I think we also prevented possible contamination of the river.
Yeah, that's remarkable. I mean, this project speaks for itself. If I look at the materials, of course, we supplied approximately 165 square meters of QC, but overall, if I look at the concrete that was used, I talk about 790 cubes. And I mean, on the structural steel side, there's 46 tons in there. So that's remarkable. That's a lot of steel used to construct this bridge, and I'm sure that, with the challenges of it being damaged previously, it's sort of in building it or constructing it in this constructability with this steel is remarkable, and that will last a lifespan. Just some of the project photos showing the deck that Permanent Formwork Solutions are currently installing there, and then the concrete that has gone on top of this. Philip, anything on your side you would like to comment on this?
No, not really. I've got no impact on when after the decking was laid and
Yes.
the flashings that was also supplied. What we opted for here, because the deck, the concrete spanned from edge to edge, there was no real opportunity to put in temporary side shuttering. So we also opted for a solution that GRS provided in making the flashings out of a 2 mil thick galvanized flashing that could act as the permanent shutter on the slab edges as well. But other than that, I was not involved in the actual placing of the concrete.
Correct, yes. And that's great to know on the steelwork constructability. Let's just have a look at the structural work. Neil, on your side, on the decking side, I mean, if I just have a look at any of the highlights that was here in terms of that, I don't know, Daniel, is there anything you would like to add input on the framing?
So the framing comes more into the design side of things, and there's a bit of information in these slides about our design process. It was a bit of a multifaceted process. We started off with Hancocks and trying to get our ballpark sizes right so that we could achieve the free boards that we wanted. The Hancocks then got finalized, and the simplified components translated into BIM or FEM modeling programs so that we could get a more accurate check on everything. And then this was then translated into exporting models to detailers to detail the steelwork so that that process could be streamlined. It also allowed us to get a more accurate view on how the loads were getting translated to the foundations, as there was some discrepancy on either side of the bridge. One side was on rock and the other side was in the alluvial bed of the river, so that required piling. And yeah, so modeling it more accurately allowed us to integrate with the steel detailers and the piling contractors to achieve the design we were looking for.
Great. All right, just some images of the QC going in on site. With the support connections, here was the aid of all of the bearing beds and the applied loads all calculated. Just having a look at the bridge in sort of its final stages once the concrete was poured, just showing that between steel, a composite deck and concrete, what can be achieved. From the BIM point of view, Daniel, anything?
Yeah, so this is more of what I was just talking about. Part of our modeling process, which was then integral into the design flow of exporting the model to the detailers and then producing an accurate model that could then be re-imported back into our civil software to make sure everything fitted and to finalize the design of the civil components.
Yeah, that's remarkable. Cool. Philip, on the deck itself, I know you have spoke about the complexity of the job, getting the steelwork in, quite a lot of personnel to get this erected and installed. I just want to have a look at the fabrication. You mentioned that everything needed to come in, due to the mine, everything needed to be transported in. Anything you would like to add on to this, Philip?
No, no. I mean, it wasn't a very difficult job because it was just well planned and well executed. So I can't even think that I can't think of a constraint that there was. The girders the steel girders were all designed as spliced units. So the fabricator responsible at that time for it did a good job in fabricating it. It was all transported in sections a bit before we reached site, but just from our side in the installation of the decking, not one of the splices were out of place. Everything fitted without a cutting torch on site. I just think it was a very well planned and executed job because there were no struggles when it came to installation of those girders and the decking then on top of that.
Right, yeah, indeed, well executed and planned.
I can come in here, Hitesh, yes. Yeah, sure. So some of the challenges on our side were the founding conditions, which we had a bit of an integrated approach with the geotechnical engineer and the piling contractors, and then our design software, which enabled us to overcome that. Another thing that we picked up that was quite interesting is in normal applications of steel, the additional pieces that you weld on for connections don't add a huge amount of weight, but in this case, with such a long span and the stiffeners required and the splice plates required, it actually added quite a large load to the structure, which we had to then come back and and design for once we'd selected what needed to go where. And then the span of this bridge is quite long, so deflections were always a concern. So we ended up having to pre-camber the steel beams so that once everything was in place, it would come to a nice flat surface, but would still meet our requirements when it was loaded.
Great stuff. Yeah, just having a look at the benefits of steel. Of course, sustainability is a big highlight here that one considers in terms of it being 100% recyclable, and the durability and the longevity of steel speaks for itself. The benefits on the engineering side, Philip, Daniel, if you want to come in here.
Yeah, so the ability to use this composite deck and take advantage of the benefits of both the steel on the lower side of the bridge and the concrete on the top allowed us to achieve the span that would have been very difficult to achieve with only concrete or only steel. And then, the offsite fabrication, as Philip mentioned, just made things much easier with steel, that we can make everything and make sure it fits and then bring it to site, plug it in, and everything can flow.
Fantastic, yeah. All right, just from our side, steel, of course, providing sustainable and effective solution throughout recyclability, durability, and rapid installation. The use of permanent formwork, the QC flooring, of course, reduces construction time, and that's a big game changer towards us in minimizing waste, eliminating any temporary formwork. With, as Philip mentioned, with the river at the bottom, this product was efficient and the go-to for us, and that's what we sort of remarkably proud of. And yeah, I think from GRS's point of view, we would just like to thank all of the project stakeholders, giving us an opportunity to be part of this unique bridge and come up with a solution. From Neil and myself, I think we just would like to extend our thanks to yourself, Daniel, and Philip, and the rest of the team at RMCE and Permanent Formworks, of course, G4 Mining Civils for trusting our products and solutions that we have to the market and doing business with us. And yeah, from SAISC side, we would like to thank you guys for the platform that you're giving us to showcase our products and services and our prestige projects. And to the team here, Neil, in closing, is there anything from your side?
No, I think you covered everything. Yeah, thanks for running this presentation. Really appreciate you as well.
Thank you. Yeah, Daniel, thanks. You and Philip, anything in closing from you guys?
No, I'd just like to thank you for putting this project forward and for running everything. And yeah, this was a very enjoyable project to work on.
Yeah.
Same here, Hitesh. Just thank you for the opportunity. Thank you.
Great stuff. All the best there. Thanks, guys.